Okay, so hi everyone. So now this is the matrix determinant. So last video was about the learning activity for this subject, determinant of a matrix or matrix determinant. In this learning activity, we talked about some properties of determinant matrix or matrix determinant. Okay, now we are going to continue with the application activity for the first point. Let us now write down the application activity. This is application activity 131. So because last time we talked about learning activity 1.3.1. So now let me just write down this activity. Okay, so now here is the activity. Question number 1. Distinguish between this element A, C, B, D, and D in vertical bars A, C, B, D. Okay, so sub question 2, number 2, calculate determinant of the matrix, a 3 by 3 matrix, 1, 1, 1, 1, 1, 2, 3, 3, 2. Okay, the matrix, it is matrix M. Matrix M. Okay, so there are two possibilities. H, by using Saros method. Second possibility, by expansion by cofactor expansion. Okay, so number 3, state whether the matrix X, whether the matrix X, so it is defined below, if it is a singular matrix or not singular. Okay, or not. If sub question A, this matrix is a 2 by 2 matrix given by the coefficient 5, -3, 0, 9, and B. So this matrix X, another matrix which is also 2 by 2, 4 times K minus 20 times K, then negative K, 5K, with where the constant K is a constant real number. It is a real number. Okay, so this is the activity to be done, which has 1, 2, 3 questions. Okay, so now if you are following this, you are watching this video, so on this application activity 3.3.1, please, you can pause or stop the video in order to try to do 1, 2, and 3. Okay, I hope that you are going to do so. Now, for the moment, let me just try to work out this question. So now let us work out question 1. Okay, maybe we can have space here on this side. Let us find so for question 1. So some answers for this activity. Okay, number 1. We hope that number 1, this space is enough. So this HCBD, when it is written in round bracket or square bracket, normally it is a matrix. In this case, this is 2 by 2. This is 2 by 2 matrix. So actually, it is a square matrix of order 2. So while here in vertical bar, normally in vertical bar B and D, normally this is determinant. It is determinant of the HCBD of this matrix. So that is the distinction between the two elements. This one is a matrix. That one is its determinant. Normally, after calculation, this determinant is going to be product of diagonal coefficient minus the product of the secondary diagonal elements. So now this is a matrix, this is a number. That is the difference, the number which is given by this difference, and that difference is exactly this determinant. Okay, so now that we have finished number 1, can remove it very quickly. We know what it is. We're looking for now question number 2 here. So number 2, we want to calculate the determinant of matrix M. So this is exactly determinant of 1, 1, 1, 1, 2, 3, 1, 3, 2. Determinant. So we can use Sarus method. Sarus method. Sarus method. Okay. So in this case, we're gonna have to add the determinant of M. So we are going to adjoin. So 1, 1, 1, 1, 2, 3, 1, 3, 2, and then we adjoin the first two columns. 1, 2, 1, 3. So now, and what we are going to do, we make this diagonal, the product plus the second plus the third, and then what you have here is 1 times 2 times 2. First diagonal, second diagonal for this one is 1 times 3 times 1. So plus now this one is 1 times 1 times 3. Okay, now this is the first one. second diagonal. Let us look at how it will look like. Is this one, product of these elements, and then these, and then these ones, with a sign negative here. So we will have product 1 to 1, 1 times 2 times 1, 1 times 2 times 1, 1 to 1, 3, 3, 1 plus 3, 3 times 1, now plus finally 2, 1, 1, 2, 1 times 1. Okay, so in this case, we will find by Sarus method here. Let me just change this color. Determinant of matrix M is going to be equal to 1 times 2 times 2 is going to be equal to 4, plus now 1 times 3 times 1 is going to be 3, plus now 1 times 1 times 3 is going to be 3. Okay, minus now 1 times 2 times 1 is going to be 2, plus 3 times 3 times 1 is going to be 9, plus now 2 times 1 times 1 is going to be 2. And what we are going to have is this sum. This is 10 minus now this one is 4 plus 9 is 13, and then the difference is negative 3. So this is the finally the determinant of this given matrix. Matrix here, this determinant is equal to negative 3. Okay, now this is one method by Sarus. This is how it works. Now cofactor expansion. Now that is subequation B. So we are going to find the same determinant by using so that is subequation B. Now we're gonna be using now cofactor expansion. Okay, so now I remove everything here. Sarus method, that was A, Sarus method. Okay, let me just name this by Sarus method. Now B here, by cofactor expansion, method. So what are we going to have? So I can expand. Okay, so either by the first row or the first column. Let us take the first column, no problem. So it's going to be, so this is coefficient. Normally, how do we expand? We use here. You could pay attention, plus and negative, positive, negative, positive, negative, then positive, negative, positive for because for the cofactor expansion, because for each cofactor, this power of -1 will alternate from one row to another, as well as from column to another. Okay, that's why we have this scheme, this picture, and now this is what we are going to have. Okay, now here we have a positive sign. We are developing along the first column. Then we have the coefficient. This coefficient is 1. So times, now I remove this column and this row. Left is 2, 3, 3, 2. Then I will have this sign minus C. And then again, coefficient which is there is 1. Now I multiply by the determinant, or when I remove this second row and first column, I'm left with the 1, 1. First row, second row is 3, 2. This coefficient. Now, next, I have the positive sign because I'm expanding according to the first column here, first column, and then I will get the sign is positive plus C. Now, this is gonna be again 1 times the determinant when I remove the last row, third row, the first column left is 1, 1, 2, 3. Okay, now what I have here is terms are determinant of lower order, exactly 2 by 2 matrix, and we know how to calculate a 2 by 2 matrix determinant. Okay, in this case, we are using the cofactor method to find the determinant of this matrix. First method of Saros gave -3, so we are expecting to get the same number by a cofactor expansion method. Now, what we got here is, so multiply by 1, no change. We have 2 times 2 minus, so 2 times mean diagonal, secondary diagonal, 3 times 3. So that is the first term. Second term, multiply by 1, no change. Product 1 times 2 minus now 3 times 1. So now second term. Third term is going to be, I add, so times 1, so no change. When you multiply by 1, there is no change, and then I have this determinant, 2 by 2 determinant. So 2 times 3 minus 2 times 1. So that is the next number, next term, 3 terms. So first term here is going to be 4 minus 9. Second term, 2 minus 3. 2 minus 3. Now third term, 3 minus 3, 2. So result. So first term is -5 minus second term -1 plus third term, which is 1. Now negative becomes positive. Then we have -5 plus 2. So this is equal -3. And likewise, we find this is the determinant of matrix M as it was expected from Saros method. Factor expansion method also gives also the same value. Okay. Now, so next is question number 3. So again, as the first and second question are done, so we can find out if the matrix is singular or not, and then this one where k is a constant real number. Okay, so let us, maybe this space will be enough for us, I think. So this will be number 3. Answer for number 3. So we have x, matrix x is equal to 5, 0 minus 3, 9. So in order to check whether it is singular or not, so we can determine, calculate the determinant of this matrix. So this is 5 minus 3, 0, 9. So it is a 2 by 2 matrix, so its determinant, I take the product of main diagonal, second diagonal, 5 times 9 minus negative 3 times 0. Of course, 0 is absorbent for multiplication, so that comes 0. We have 45 minus 0, which is 45. This determinant being different from 0 means that the matrix is not singular. The first matrix, this means that the matrix X, which is 5, 0, negative 3, 0, 9, is not singular. Because its determinant is different from 0. Now, suppose that now the matrix here X contains some parameter like K, which is a constant real number. Now in this case, we're gonna look at its determinant. So it's going to be equal to 4k, 20k first row, second row, this is negative k, and 5k. Okay, so now this is equal to, so by using properties of matrix, I can let suppose so this matrix, of course, this is negative 5, and if I multiply by negative 4, I'm gonna get the first row. So now here I can get for the first row, this 5 times negative 4 is negative 20, so this matrix is singular because it will be equal to, if I factor k out, 2 times k for the first row, and if I multiply by suppose negative 4, so it will be negative 4k first time, but I have to, for the second row there is also a k, so that I have now to multiply by negative 4 for the first row, so it is going to be negative 1, negative 1 down, and then 1 here, and then wait, so it's not 1, it is negative 20k divided by negative 4k is going to be equal to 5. So this is 5 also. So now it has got 2 equal rows, so of course determinant is going to be equal negative 4k square times 0, which is 0. So it could have been already checked that it is just 0, because here if you look at the first row, as we said, is a multiple, the scalar multiple of the second row, because the second row is negative k, 5k. Now, if I multiply by negative 4, it becomes 4k, negative 20k. Okay, so from this property, so from this fact, the determinant already is equal to 0. So, which means, what does it mean? It means that the determinant x, here we have, including k, is equal to 0 for any k, for any real number k. Now, and what does it mean? It means that the matrix X, which is equal to originally it is 4k, negative 20k, negative k, positive 5k, is exactly singular. which means that its rows as well as its columns are not independent. One depends on the other. If we fix the second one, for example, so the first one will be its multiple, which means that its row are not dependent. And the columns also, if you fix the first one as 4k, negative k, so we see that the second, if I multiply by negative 5, I'm going to get the second. So it means in terms of column, 5 times negative 5 times the second column, the first column, sorry, first column is 4k negative 1. So if we make such multiplication, we're going to get the second one as it's going to be negative 20 k and 5k. So which means also that the determinant already, without calculating anything, at the beginning we see that this matrix determinant is equal 0, which means that the matrix is singular already. So okay, so now we have come to the end of the correction for this application activity 1C1. So next time we're gonna be looking at other activities involving matrix determinant. So until then, have a good